This geometry is being deformed by a neural deformer. Okay, so this is how I went about creating the neural deformer. First, I created the data that I used for training my neural network, and this is the file that I used for creating that data. So here I just have a normal plane, and then I have FFT to bulge this portion of the mesh, and then I have a wave deformer, and then I have animated it, scaled it, and then I'm outputting the vertex position and the locator's position. Locator is this one, under which this FFT and the wave deformer are parented. The data that I generated looks like this. The CSV file is not showing it correctly, but the data is in such a way that first I have the world metrics of the locator. Then the last three numbers are the points, the world position of the points of the geometry as that is being deformed. And as you can see, I have more than 80,000 lines of data that I've generated, which I used on training the AI model, the neural network. Let me show you the neural network. So this is the neural network that I built and then I trained. And then I created a Python deformer so that I can use this neural network in Maya. This is the Python deformer. So basically what this deformer is doing is taking the input value of the connected locator and the vertex position of the geometry, and then I'm calling in the neural network. This is the trained model of my neural network which is being loaded. Then I'm feeding the data here, and then the neural network outputs the values which then I use to deform the geometry in Maya. So let's now see it in Maya. Let me first create a geometry with the same resolution that I used in the training phase. So I've written a simple code to help me fasten up this process. First I'm creating a locator, then I'm creating a plane, then I'm setting the subdivision width and height to the value that I defined here in the res. Then I'm deleting the history, scaling the plane so that it matches with the trained geometry. Then I'm freezing the transformation on it. I'm creating a duplicate mesh which I'll treat as a origin mesh. Now I'm adding the deformer, creating a deformer on it. You can see it up here in the channel box. Now the neural deformer has been created on the geometry. Then I'm creating the locator of the geometry, and then I'm loading the origin mesh. So now you can see that this geometry does not have the deformer FFT or wire deformer, and it is being completely deformed by the neural network. But this is a low resolution model. But once the AI, this neural network model is trained, then it is resolution agnostic. What I mean by that is I can create another mesh with much higher resolution and it will still work. Of course it will be slower because the deformer that I've created is a Python deformer. So my next update would be a C++ deformer. So now this mesh is being deformed by the neural network. So basically what I was trying to do is create a stack of deformers, train a neural network to see what those deformers were doing together. Once the neural network is trained, you can get rid of that stack of deformers and just have one single neural network deformer, which then deforms your geometry. And once the deformer is in C++, it will be much faster than the stack of deformer itself. So that's about it. Thanks for watching.